logarithm of the amount of time. No. Okay, so Kate and Pippa are disagreeing about the solution to this logarithmic equation. Here's Kate. Kate got two answers, 10 and negative 10. Pippa also got 10 and negative 10, but she rejected it. Yeah, because the argument of logarithm must be greater than 0. Okay, so who's right, Kate or Pippa? Look at what they did. Look at the problem. And who is correct? Both, neither. One of them's correct. It's Kate. Why is it Kate? Because she's the future queen and we're not going to argue with her? Yeah? No. It is Kate because what are you doing to that number? You square it, and when you square negative 10, it's always going to be a positive. Right? So Kate's correct. The argument x squared always going to be positive. Always. Alright, let's look at number 7 here. I can tell you that's not enough room for me. I'm going to need to write this on another piece of paper. Okay. So, log x3, x minus 4. Plus log x3, x plus 2. Equals what? Alright, so here's what we're looking at. We want to solve this. We're going to have to use our properties and what we did yesterday. So first, the properties, that addition means that I have to what? Multiply. So I'm going to start off by multiplying x minus 4 times x plus 2. So that's going to be x squared minus 2x minus 8. Right? Multiplication, addition, multiplication, they're the same thing. To get from here to here, I FOILed. That's what I did. I did it in my head. Okay, that's all I did was FOIL. Alright, so we now have a logarithm with the argument missing. If the argument is missing, how do we solve that? Exponential, so I'm going to have 3 to the third equals x squared minus 2x minus 8. Alright, what's 3 to the third? How do you solve this? Then what happens? Factor that. Yeah, what are two numbers that when multiplied will equal negative 35 and when added will equal negative 2? Negative 7 and positive 5. Right. And A is 1, so I don't have to go through all those steps with A being 1. I can just go to 0 equals x minus 7, x plus 5. Okay, so that means x is either 7 or negative 5. Alright, you gotta check it. You've got log base 3, 7 minus 4, plus log base 3 of 7 plus 2 equals 3. log base 3 of 3 plus log base 3 of 9, log base 3 of 27 equals 3. That's right, 3 to the third is 27, right? Yes, 3 to the third is 27. So that one works. Let's check the other one. Log base 3 of negative 5 minus 4. Okay, we have a problem. This is log base 3 of negative 9 plus log base 3 of negative 3. The argument has to be greater than 0. And that neither of these are greater than 0. So this one's out. That is an extraneous solution. Our only answer that works is 7. Because negatives are undefined. I can't take, okay, remember, a logarithm is the inverse of an exponent, okay? I can't take an exponent to any power and end up with a negative. It doesn't happen. So, if it started out positive, it's always going to be positive. And remember, this is the answer to that. So it's not going to be negative.
So even if it's 1
Right. You can put it in your calculator. In your calculator, let's just try change of base with this. Do log of negative 9 over log of 3. See which calculator comes. Said what? It says error. It says error. Can't do it. You can't have that negative there. Error. Now you can have some negatives in there. If that had been maybe bigger than a 4, or smaller than a 4, bigger than a 4, and we were maybe, if it ended up being positive, that negative 5 might have worked. Like with Pippa and Kate, that negative 10 was okay because immediately I squared it and it went away. But it doesn't go away here. That's the problem. Okay, look at Elijah and Xander on the next page. They both got the thumbs up, so they're both correct, but they didn't do it the same way. So explain why each one is right, even though they're not the same. I'm going to pause this while you read. Okay, hang on 1 second. Xander moved the log of x minus the log of 2 across the equal sign. So that changed their sign. Okay. Alright. And then he made that, since it's a minus, anything following a minus is going to be division. So, and then anything following plus sign is multiplication. And so then once he got it right here, he had a missing argument, so changed it to an exponent. Alright. That's good. When you check it. What about Elijah? What did Elijah do? Yeah, remember, if this log equals, if the log on this side equals the log on this side, then you can get rid of the log and just be left with what's there. Okay? If two logs are equal, then the arguments have to be equal. Okay? So he did that. Which way do you like better? Elijah? Yeah? I'm going to do 9A with you, and then you're going to do B, C, and D on your own. Well, sorry. So let's look at 9A. How would you like to solve it? Condense it. So that's going to be log x plus 1 squared equals log of x times x plus 3. What can we do from here? Yeah, if the two logs are equal to each other, then their arguments have to be equal, so that means x plus 1 squared equals x times x plus 3. What is this squared? Uh-huh. X squared plus 2x plus 1. And this would be, yep, this is going to be wonderful if we learn that, we're going to have the factor. Looky here. Looky. X equals 1. Check it. That's X equals 1. Now put that back in there. Did it work? Put that back in. I'm going to have 2 times the log of 2 equals the log of 1 plus, okay, let me just run out of room, plus the log of 4. The log of 2 squared equals the log of 4. Does 2 squared equal 4? Yeah, so that's your answer right there. Alright, turn the page and do the rest of number 9. So for question B, use your properties to condense this back together. So that's going to be log x minus 3 squared equals log 4 times x minus 15 over 4. Right? Okay, and then what can I do now? That I have log of this equals log of that. Yeah, just stop the log. Stop them. Not on your toe. Square this. What do I get when I square that? Distribute this 4. X minus 15. Combine your like terms. When I combine like terms, I'm going to get x squared minus 10x plus 24. What are two numbers that will multiply to be 24 but add to be negative 10? Negative 6 and negative 4. So x could be 6 or x could be 4. If I check those, I think they both work. You get 2 3 squared equals both of these work. We'll go for it. Alright, let's try the next one. What can I start out doing? What? Condense it. So what's it going to look like? Natural log. Alright. Now I can drop the natural log. What is this multiplied by? When I combine like terms, what do I end up with? Minus 18. What is that factor to? Two numbers that multiply equal negative 18 and add to be a negative 7. 2 and negative 9, right? So I have 9 and negative 2. Check them. Did we get that far? Do they work? Do they both work? No, we don't know. Check them. Nine works. Oh, I just wrote one for you. Guess what? Negative 2 doesn't work. Because I end up with negatives here. Can't have that. I end up with the natural log of negative 5 plus the natural log of negative 4. So that's a bad deal. So it's extraneous for negative 2. It's still writing blue. Okay, got it. Alright. Last one. So I have log base 3 of x squared equals log base 3 of 64. X squared is 64, so what's x? 8. We know it can't be the negative one. Make sure 8 works. I'll put 8, yeah, it's going to be 8 squared equals 64, so we're good. The answer is 8. It works. Okay, let me ask you just really quickly, quick review. If the argument is missing, what do you want to do? Change the exponential. If the exponent is missing, so like if I have log base 12 of 17 equals x, what do I want to do with that? Change the base, and if the base is missing, exponential. Great. Alright, look at your still